Hello everyone, welcome to this new webinar from our series Zetta Scale with Eclipse Zenoh and with robotic for this time. I'm Julien Enoch, solution architect at Zetta Scale, and I'm enjoying today to have a guest which was with us at ROSCON a few weeks ago, Pradheep from Neobotix. Hello Pradheep.
Hi Julien.
Welcome for this webinar. And so Pradheep, can you please start to introduce yourself and introduce your company, Neobotix?
Yeah, sure. First of all, I would like to take the opportunity in thanking Zetta Scale for organizing us in ROSCON, and as well as thanks for the opportunity that you have provided us now. So I really appreciate it.
It was really a pleasure to have you in your booth, and with moreover with the nice demos that you bring, you Neobotix, but also with your partner Synergeticon. We have
Exactly.
two nice demos to show, and we will show another one just today.
Yeah. So before that, I have a short presentation that I would like to show you guys. Let me quickly share the screen. Give me a second. Hmm. Da-da-da-da-da-da-da-da. Okay, there is a small issue. Let me just quickly open it. Okay, coming up in just a second.
No problem.
Okay, I'm going to share the entire screen now. For some reason, I'm not able to pick the presentation slide. So can you see my screen? So
I
it
think
should
we
be,
can. Yes.
yes. Okay. So let's do the introduction. So hi guys, my name is Pradheep Padmanabhan. I'm responsible for all the ROS-related development at Neobotix. I've been working here for the last let's say 6 years, and it has been a great learning curve since then. So now comes the interesting part, what Neobotix does. So Neobotix is a manufacturer of autonomous mobile robots. We manufacture robots for indoor applications such as transportation, interlogistics, and measuring applications. Um, our founders have been designing and building robots for the last for more than 20 years now. We have successfully shipped more than 150 robots across the globe. One of the major strengths of us is to do high customization. For example, if you have a specific use case and you need a robot beyond our standard platforms, or for that matter of fact, any other vendor from any other vendor, you don't get the specific requirements that you need. We are there for you, and we will be able to build the robot. And for the software, we are one of the first companies to provide full ROS2 support. And yes, we also support JASI. The other one we have is our own proprietary software platform pilot, which is a turnkey ready solution. That is a whole different topic, and we need a separate webinar for that. Last but not the least, we are located in Germany. All our robots are manufactured in Germany. We are located in a place called Seilbronn, which is close to Stuttgart. Going on further, to give you an overview on where our robots could be used, I have brought you here 3 applications. So one on the left is our scanning robot, which is used for scanning large industrial components, or you could also use to scan the helicopter as shown here. This makes it more time efficient and as well as cost efficient, rather than using a trained human employee spending tons of hours in scanning the industrial components. On the right, you can see the MPO 700, a modified version of MPO 700, which was redesigned for a research project. So here, the ultimate aim was to use mobile robots in the manufacturing of aeroplane industries. You can imagine, like, I hope most of you guys would have been in an aeroplane. So you can imagine like how small the door of an aeroplane is. So we were able to do the customization and was able to successfully get the robot through the doors. And the third application that you have at the bottom is a transportation application where our differential drive robot MP400 was deployed in a industry which manufactures drives. It is quite famous a company in Germany. Moving on further, um, so rocks. I guess everybody who should know Neobotix should also know Rocks. Rocks is our flagship platform. It was designed in a way that it is highly modular, so that in case if a customer comes up with any customization, or if he wants to do the customization of his own, it would be possible. We have for this robot, by default we have two safety laser scanners, one on the front and another on the rear. So this safety laser scanner is utilized for both collision avoidance and as well as of course the ultimate priority, the safety. So this robots comes in two variants. One is the differential kinematics variant, and another one is the omnidirectional variant. So we here have sub variants. So for the differential one, we have the trike and the diff, and for the omnidirectional variant, we have Argo Duo, Argo Trio, and Argo. So all these Argo platforms are built upon using our Argo Drive modules. So Argo Drive modules is something like you can imagine the wheels of your office chairs, but here both the caster part, both the steering, both the caster part and the wheel part are powered using the motors. So I personally call it as powered casters for ease of understanding. Um, so I think since we are short on time, I will not be able to go through all the differences. But to give you some specification, our differential robot has a payload of 300 kgs, and our for the omnidirectional Argo Duo has a payload of 300 kg, Trio 400, and the Argo, which is the topmost variant, has a payload of 500 kg. The maximum speed our differential robot can go is 1 meters per second, and the Argo drive can go up to a maximum speed of 2 meters per second. One information that I forgot to put in here is about the batteries. By default, all the robots are provided with the AGM batteries. As an add-on, we also cover the lithium-ion batteries. And for the purpose of charging, like any products out there in the market, we offer wired charging. And in case if you want contactless charging, we also have the induction option, which we can add it as an add-on. And the robot that you see here on the right side is the mobile manipulator. So mobile manipulator is nothing but we have a mobile robot and a manipulator put on top. So you will be able to use the respective planning APIs to control both the robot arm and as well as the mobile platform. So the robot arms in our standard configurations that we provide are the elite robot arms and the universal robot arms. But it is not just limited to that. If you have any other robot arm in the mind, and if we would just check for the compatibility, in most of the cases we would be able to integrate any arm of your choice. And last but not the least, we have the software. We here have the software packages on the right. So I want to go from the bottom. The navigation 2 stack is utilized for the motion planning of the mobile robot. One of the other reasons why I wanted to start with Navigation 2 is because we are one of the co-maintainers of the Navigation 2 stack. Of course, Steve Masinski from Open Navigation does the major part, but we help him whenever we have some time. Then, speaking about helping, we are also currently giving tons of feedback to Zetta Scale about Zenoh, and Zenoh will be the default middleware for all the robots that we will be delivering with ROS 2 chassis. Uh, we already have a couple of customers who have ordered robots with Zenoh as the default middleware.
That's great.
Before that we were using Cyclone DDS. I guess that was also from the team of Zetta Scale.
Hmm.
uh, and and for the manipulation part we use Move It 2 um, from the famous Picnic Robotics. Yeah. So
Hmm.
this was a very quick short introduction on what we do at Neobotix.
Yeah.
If you like to know more about Neobotix, you can get in touch with me directly on LinkedIn. You can email me at ross@neobotix.de. Of course, you should scan the QR code and you should be landing up in the Neobotix webpage. And as part of this webinar, we are offering an additional 5% discount on all our Neobotix products running with Ross. Additionally, we also offer a free Zetta platform trial. I guess Julien would be happy to see this.
Yes, absolutely. Yeah.
In case if you are planning to buy a mobile robot, please do consider us, and please also use the code NBXZeta. And
Yeah.
yeah, I'd be happy to help.
Yes, and that will be very nice because all of you then can reproduce the demonstration that we will show right now, and the demonstration that we had also in Roscon in Odense 2 weeks ago. Right, it was
Mhm.
exactly the same robot, but with a scanning camera. Right, we had this
Exactly.
very nice setup from Synergeticon with a kind of panel from
Mhm.
an airplane, and we saw the robot arm scanning the panel,
Mhm.
and all moved thanks to Move It and to RMW Zenoh on
Mm.
Ross JZ underneath, right?
Yeah, exactly. And
And
and you
actually,
forgot navigation too.
navigation too, yes, for the movement, but that was actually more the focus on a second demo we had on our booth,
Yeah.
which was also with one of Neobotix robot, but the robot was actually in Germany, and we were able in Odense from a laptop in the conference center to visualize all the lidar information, the navigation to cost map, and to send navigation goal to the robot directly. And yeah, so I think we get very warm feedback from all the community at our booth with those demo, right? Pradheep,
Mhm.
I guess you agree. You get
Yes.
lots of questions on the setup.
Yes. I met a lot of people, and they were really happy to see the advancements that we have made, especially with the online demo, like connecting the robot from Modins to Germany. That was like was amazing. Yeah.
Yeah. So, by the way, let's do it again, right? Because right now we
Yes.
have set up with not exactly the same robot that we had in Odense, but with a more evolved robot. Because in Odense, the robot in Germany was only the ROX platform without arm. But today
No.
we have you
Uh,
set up the robot with the arm, right?
yeah. This is the Mbrox platform that I was explaining you about
Okay.
earlier.
Yeah.
So it has a UR10E arm on the top, and on at the bottom is the ROX Argo platform with the four Argos. So it's an omnidirectional platform basically. So
Yeah. So mainly, can we say that it's actually two robots in one?
exactly. So both the robots are connected to a single onboard computer.
Mhm.
So any commands that are given should be given through the specific onboard computer.
Okay, yeah. So actually, what we see here is a live feed from a camera. So by the way, this video feed is not using ROS, right? Because it's an external camera filming the robot. It's not connected to the robot and not using ROS. But the robot itself is using ROS JZ with RMW Zenoh, right? And
Mhm.
it's actually also connected to our Zetta platform. So the Zetta Platform is a platform as a service where you can deploy, provision and deploy Zeno router in the cloud. So here, for instance, we have one Zeno router deployed here in Germany on AWS account in Germany. The Zeta Platform generates automatically all the certificates and the configuration for your purpose and for security of connection. So what we did, right, Pradheep, is just I provide you the configuration file for the Zenoh router deployed in your robot, and I'm using the same configuration file but with a different name from my laptop here. So just to show to everybody what's the configuration look like. That's the one on my laptop. So that's Zenoh configuration file, the exact same that you may have, that you can see in the RMW sources, right? There is a default one. We just copy it and change it a little bit to add this metadata, which is provided by the Zetta platform. Also, the connect endpoint. So here we have two endpoints, TLS and quick. So we can test TLS or on quick at the same time. So here, for instance, both are configured. And there are two connections. Only one will be used, but still, if TLS get down, for instance, we can fall back on quick. Zenoh will automatically fall back on quick connectivity. So of course, both TLS and quick need certificates. So if we go down into the configuration, we can see that I added all the certificates and private key here for the TLS configuration. And actually, they are just put as base 64. And you can see also that we have the client authentication, which is set to true, meaning that only me as a client, I can connect to the platform with the correct certificate. Anybody with wrong certificate will not be able to connect to the router in the cloud. So we have a secure connectivity from your robot to the cloud and from my laptop to the Zenoh router in the cloud. So, and we can see in the platform that everything is running. All the little picture here are just ROS nodes, which are already running and connected to either to the cloud, either to my laptop. And in my laptop, actually, I have two RVs started, but also just a console here, for instance. And so let's see at first with ROS2 command what I can see from your robot here from France. So if I do a ROS2 node list, of course, the ROS2 daemon is started. It will get all the discovery information, and we can see all the ROS nodes that are running in your robot. Right, we can see all the navigation, the LiDAR nodes, the move it nodes, and we can see also my local RVs node. I have two RVs running in the background for the demonstration purpose, and they are running right now. I can also do a ROS topic list, for instance, and yes, in just 2 seconds, we get the list of all the topics which are running. And so we can get all the information about the running robot from France to Germany. And I can also try, for instance, to get some data, right? If I can try to get odometry data and to check what's the frequency of publication from odometry, what do we get? And here we can see that we get your odometry publication from the robot at about 50 hertz.
That's right. Yeah.
Yeah, that's a rate of publication in your robot.
Exactly.
Right?
Exactly.
Yeah.
That's
so
the value we have set. Yeah.
Perfect. So it seems we don't have any loss of messages. It seems very, very good. So by the way, you may ask, what's the latency, right? Actually, the latency will be just the latency you have with the cloud. So for instance, from my laptop here, if I copy paste the host name here and do a ping to this address, you will see that we have, actually, no. Unfortunately, the cloud is secured and it is not replying to the ping. So it was just an attempt, but we cannot check exactly the latency that we have with the cloud. But anyway, it's just a matter of few, maybe 100 milliseconds at most, but probably less than 100 milliseconds. And this twice. The overhead of Zenoh on this is just few microseconds. Few microseconds in the robot, few microseconds in the router, and then few microseconds on my laptop. But that's very negligible with regard to tenths of millisecond on the network latency. So what will matter here is really the network latency that you have. But thanks to the Zetta platform, you can choose the region where you will deploy the Zenoh router. So the best is you deploy a Zenoh router close to your robot or close to your teleoperation, right? So now let's see what we get with the RVs. So we have RVs here already running, which is showing all the LiDAR information from the robot. So by the way, I will switch here so we can see the robot. The navigation pose are already been estimated.
Yeah.
And now I can try to send a goal, a navigation goal. So for instance, I will move the robot just here. So here, the sound we heard was the brake, right? The
Exactly. It was the brake opening. Yeah.
brake opening, and now the
It should
brake.
it should close now. Yeah.
Yeah, it's closed. So and you can see that the commands are quite fluid, right? As soon as I send a command, the robot is moving, and we can see also that in the LiDAR that all the LiDAR information is almost in real time, right? With only the goal latency. So that's for Nave 2. We can see that we can get all the information from Nave 2 remotely. And now let's check with Move It, right? So here there is RVs with Move It. We can see the status of the position, the current position of the robot arm. So now let's try a goal to send it up, for instance. So we will move the arm of the robot in this position. Let's plan the movement. So here, if I understand well, correct me if I'm wrong, Pradheep, but the movement are computed on my laptop, right?
Exactly.
Yeah. And now if I do execute, it will send the command for the movement directly to the robot. And we get
Exactly.
live feedback directly in RVs. And it seems the latency is quite good, right? Because we cannot see so much difference between the video feed and the visualization in RVs, right?
Exactly. I just turned to look. It's like almost like very real time. Yeah. It's just milliseconds.
That's perfect. So let's move back to the test configuration. So now we can do directly plan and execute, and it will do the planning and the command, send the command for the movement at the same time, right, in live.
Exactly.
Yeah. So here we can really see the synchronization of the movement between RVs and the remote robots. That's really a digital twin in live from France up to Germany.
Exactly. Yeah.
Yeah. So I think that's already a quite very good demo. And so, what would you expect to do with such a use case? Does it open new use case for your company or for the customer of yours?
Of course, yeah. You can already imagine. So when you have a fleet of robots being deployed, say for example in India, that's the place where I come from, and you are sitting in Germany and then want to debug something in India or deploy something in India, this tool will be definitely handy for us. Yeah.
Yeah, that's already quite a nice use case, yes, for analysis and debug. So I think I saw there is already one question in the chat from John Mann, which is asking, can we monitor the bandwidth consumption between the connections on the platform? So actually, yes. Let me show you if I can in the platform here. There is some a page showing the project metrics. So, by the way, this is the version of the platform which is prior Zenoh V1. The Zenoh V1 will come with a new version of the platform. So, by the way, Zenoh V1.0 has already been released, but the platform is currently upgraded and will be released soon with a new brand, with a new design for the graph, but also more information with regard to all you can monitor from the cloud. So here, for instance, you saw that we can. Oh, sorry, I get my page which was disconnected. So let me just relog. But you saw that we can see already the curve of consumption for the bandwidth in the platform. So let me just show it again. So if I'm going here, in project metrics. Yeah. Here you can see we can get all the traffic from query. So there is not so much queries, right? It's mainly all the traffic is dominated by all the publications. And we can see here all the publications, right? We have publication in pink, and for other administrative purpose, for instance, it's in blue. So there is not so much publication for the administration space of Zenoh. All ROS is using the regular publication from Zenoh, so that is the green, the purple, sorry, the pink color. So you can have different view of this per second or cumulative, so you can monitor exactly what you are consuming for the platform. And then knowing that in the platform, when you subscribe to the Zetta platform with by default with the smallest instance, you get for free 500 gigabytes of bandwidth per month, which is already quite sufficient, right? We saw that for this very basic use case. Well, actually, the project is running for a while, so we already consumed almost 2 gigabytes, right? It was for the testing from science. I think we set up this project yesterday, right?
Yeah, exactly.
And it was running for a while. We did quite some tests, but it's 1 gigabyte per day. But if you have 500 for a month, that's good enough, right? So that's all what we can see today. I think that was the demonstration that already gets a lot of interest from all the attendees in Roscon, right?
Exactly.
People wanting to try to send gold to the robot. And and thank you very much, Pradheep, for setting this up with us. And I think yes, we will collaborate further to enhance our support of Neobotix
Of course.
with Zenoh for all your robots, and for the future version of Zenoh with of RMW Zenoh with Zenoh 1.0, which is coming very soon.
Yeah, looking forward for it. Yeah.
So I see there is another question from Joan Mann. Does it allow to integrate ROS1 based system and teleoperate like you do with Neobotix robot? So we had a ROS1 plugin actually, but it's never left the POC stage because we didn't saw a lot of interest from the community for it. But if you're interested in ROS1 plugin, contact us, and we can see if we can find some resources to revive it with the latest Zenoh version and to further test it, right? Because we also lack of robot running with ROS1, so we would need to have some help to test it and to make sure it's working quite well. But technically, as soon as the ROS1 plugin is working in the same way that we did with the ROS2 plugin, you should be able to do the same kind of demonstration. Yeah.
Time to move to ROS2.
Yes, of course, it's time to move to ROS2 because, as you know, ROS1 will be end of life very soon, right?
Exactly.
When does it end of life?
Next year, May, I think, if I'm not wrong.
Yeah, in May. Yeah.
But I think someone is going to extend the support.
Okay.
Yeah, but I'm not sure.
Okay, so maybe maybe it shows there are still some interest for ROS1. So anyway, if anyone is interested, you can contact us and we can discuss. So, guys, if you have any other questions, it's time to write any questions in the chat. So just a last comment from John Mann. This basically tackles some of our teleoperation use cases. Perfect. So yes, John Mann, you can already do the exact same teleoperation that we are doing right now with your robots as soon as you will move to ROS2. So I think that I don't see any other further questions. So anyway, if you want to see again how this is working, you can review this video very soon. It will be available on YouTube. You can contact us on via LinkedIn, via email, or via Discord if you have further questions. And yes, you can contact Pradheep, of course, if you want to try a real robot, a real Neobotix robot, customized for you and with a Zetta Platform trial just for you. Oh, we have a new question from Sushetan. Thanks for this. Thank you, Sushetan. I'm gonna to try Zenoh as app. Yes, very good. And please give us some feedback, right? Because we are testing it right now. We have a lot of testing already successful with an F2, with Moveit and so on, but we need more testing. We need more feedback to see if it's working for anybody. So your question, how hard is it to configure the zero copy communication? So you're talking about the shared memory, right? So shared memory is already supported in RMW Zenoh, but not with zero copy yet. So it's for the time being, it's not enabled by default. It means you need to build RMW Zenoh with a specific flag to enable shared memory. And this shared memory usage will still have a copy because the serialization is still made in CDR from your type to CDR, and this serialization is made directly into the shared memory buffer. What we have already available in Zenoh 1.0 is a true zero copy where you can provide your own memory allocator. But there is not yet an API to use this from RMW Zenoh. So we are working on this. We are working closely with Intrinsic to find a solution to enable you as an application developer or ROS application developer to access the shared memory allocator exposed by Zenoh, and then hopefully you will be able to directly create your type and allocate your type in shared memory with zero copy. So you can already test it, but a more evolved version will come later in the coming months. And I think we already have a customer for you, Pradheep. John Man say he would like to buy 100 Neobotix robot if you can. If you can.
Yeah, sure.
Hopefully you will come soon.
Hopefully,
John Man,
yes.
thank you.
Hopefully.
Thank you. So we thank you all for your attention. I don't see any further questions. So it was really a pleasure to host you again, Pradheep, for this very nice demo. Thank you very much for your efforts, and see you soon.
See you soon. Yeah.